Right now, astronomers around the world are fundamentally rethinking how we search for alien life. And it's all because of a single mysterious object that appeared in our solar system and shattered every assumption we had about what extraterrestrial visitors might look like. For decades, the search for extraterrestrial intelligence has followed a simple premise. Alien civilizations would announce their presence through radio signals, megastructures, or other obvious technological signatures that we could recognize using human science. We built massive radio telescopes, developed sophisticated algorithms, and scanned the skies looking for patterns that screamed, "Artificial intelligence made this." We were looking in all the wrong places. 3.1, ATLAS, the interstellar object that has baffled scientists since 2019, is forcing us to confront a disturbing possibility. Advanced alien technology might be indistinguishable from natural phenomena to our current detection methods. What we've been dismissing as strange cosmic objects might actually be the very evidence of alien intelligence we've been desperately seeking. Here's what makes this paradigm shift so profound. 3I, ATLAS, exhibits properties that violate known physics, demonstrates impossible energy outputs, and follows trajectory patterns that defy natural explanation. Yet it took years of intensive study before researchers even began seriously considering that it might represent alien technology. If this object is artificial and mounting evidence suggests it could be, then we've been staring at proof of extraterrestrial intelligence while categorizing it as an astronomical curiosity. Dr. Avi Loeb at Harvard University, who first proposed the artificial origin hypothesis for Oumuamua, and now 3I Atlas, captured the implications perfectly. We've been searching for alien intelligence using human preconceptions about what technology should look like. But civilizations millions of years more advanced than us might create technology so sophisticated that they appear to be natural phenomena to our primitive understanding. Tonight, we re-exploring how 3I Atlas is revolutionizing astrobiology and forcing scientists to develop entirely new approaches to detecting extraterrestrial life. You're about to discover why this single object might render obsolete decades of SETI research, how it's inspiring new detection methods that could find alien intelligence hiding in plain sight, and why the implications extend far beyond astronomy into fundamental questions about consciousness and cosmic evolution. But first, consider this. Every day, our telescopes detect thousands of cosmic objects exhibiting unusual properties. Asteroids with strange rotation patterns, comets with anomalous compositions, stellar phenomena that don't quite match theoretical models. Based on the 3IATLA's revelations, how many of these natural anomalies might actually be evidence of alien technology that we systematically misinterpreting? The traditional approach to searching for extraterrestrial intelligence has been built on anthropocentric assumptions about how advanced civilizations would behave. We assumed they would want to communicate with primitive species like humanity. We assumed their technology would be recognizable as artificial to our scientific methods. We assumed they would use energy inefficiently enough to create detectable waste heat or electromagnetic signatures. 3.1 ATLAS is demolishing every one of these assumptions. If this object represents alien technology, it suggests that advanced civilizations might prefer subtle observation over obvious communication, might use physics we don't understand to create technologies that appear natural, and might operate with such efficiency that their activities remain invisible to current detection methods. The implications cascade through every aspect of astrobiology. If alien intelligence can masquerade as natural phenomena, then the hundreds of unexplained cosmic objects cataloged by astronomers might represent a vast library of extraterrestrial activities that we've been filing away as awaiting natural explanation. The strange stellar variations that led to speculation about alien megastructures, the fast radio bursts that defy conventional physics, the anomalous asteroid orbits that suggest unseen gravitational influences. All of these mysteries take on new significance when viewed through the lens of the 3I-ATLAS revelation. Dr. Jill Tarter, former director of the SETI Institute, acknowledged the paradigm shift. 3I Atlas has forced us to realize that we might have been looking for aliens while wearing blinders. If advanced technology can appear indistinguishable from natural phenomena, then we need to fundamentally redesign our entire approach to the search for extraterrestrial intelligence. The technological implications are staggering. Current SETI methods focus on detecting intentional signals or obvious technological signatures. But if alien civilizations can create objects like 3I Atlas that demonstrate impossible physics while appearing to be natural comets, then technology gap between human and alien capabilities might be so vast that we need entirely new conceptual frameworks even to recognize their presence. This isn't just about upgrading our radio telescopes or building more sensitive detectors. It is about developing new ways of thinking about what alien intelligence might look like when it is operating according to physical principles that human science hasn't discovered yet. If you're fascinated by how a single cosmic object might be revolutionizing our search for alien life, hit subscribe and give this video a thumbs up. And here is something to think about. If we've been misinterpreting alien technology as natural phenomena for decades, what does that say about our readiness for actual contact? Comment below with your thoughts. The journey we're about to take will challenge everything you thought you knew about the search for extraterrestrial intelligence. We'll explore how 3I Atlas is forcing scientists to question fundamental assumptions about alien detection, discover new methodologies that might finally reveal the cosmic civilizations that have been hiding in plain sight, and grapple with the unsettling possibility that we might not be alone in the universe. We might just be too primitive to recognize our cosmic neighbors. The revolution in astrobiology begins now, and it all started with a single mysterious visitor that refused to behave like anything we thought we understood about how the universe works. Chapter 1. Failed Detection. The story of how 3I Atlas has revolutionized our search for alien life begins with a sobering admission. If this object represents extraterrestrial technology, then humanity's most sophisticated efforts to detect alien intelligence have been fundamentally misdirected for over half a century. When the search for extraterrestrial intelligence began in 1960 with Frank Drake's Project Ozma, the underlying assumptions seemed logical and well-founded. Drake pointed a radio telescope at nearby stars, listening for deliberate signals that would announce the presence of technological civilizations. The reasoning was straightforward. Any species advanced enough to build interstellar communication systems would want to make contact with emerging civilizations like humanity. Dr. Frank Drake's original equation, which estimates the number of communicating extraterrestrial civilizations in our galaxy, includes factors for the fraction of civilizations that develop detectable technology and choose to transmit signals. The entire SETI enterprise has been built on the assumption that advanced aliens would be both detectable and communicative. 3I Atlas suggests these assumptions might be catastrophically wrong. Dr. Jason Wright at Penn State University, who's led multiple SETI initiatives, analyzed what the 3I Atlas anomalies might mean for traditional search methods. His conclusions were disturbing for the entire astrobiology community. If 3I Atlas represents alien technology, then we've been conducting SETI while fundamentally misunderstanding what we should be looking for. We've been searching for civilizations that announce themselves, when the evidence suggests they might prefer to remain hidden. The technological signatures that SETI has prioritized, radio signals, optical pulses, infrared waste heat from megastructures, all assume that alien civilizations operate according to thermodynamic and engineering principles familiar to human science. These searches look for energy inefficiencies, communication attempts, or large-scale construction projects that would be detectable across interstellar distances. But 3ITLAS demonstrates energy management that exceeds known thermodynamic limits, exhibits behaviors that suggest controlled rather than natural processes, and maintains sophisticated functionality while appearing to be a simple comet. If this represents alien technology, then advanced civilizations might have achieved such mastery over physical processes that their activities produce no detectable waste. Signatures. Dr. Claudio Maccone at the International Academy of Astronautics spent decades developing optimal strategies for interstellar communication. His analysis of 3I Atlas forced him to confront uncomfortable questions about SETI methodology. We've been assuming that advanced civilizations would want to communicate with primitive species like humanity. But if they've been observing us for decades or centuries, they might have concluded that contact would be premature or unnecessary. The observational biases that affect SETI searches compound this detection failure. Radio telescopes are optimized to detect artificial signals against the background noise of cosmic radio sources. Optical SETI searches look for laser pulses or other deliberate light patterns. Both approaches assume that alien intelligence would use technology similar to human communication systems, just scaled up for interstellar distances. 3.1. ATLAS operates according to completely different principles. Its anomalous properties suggest control mechanisms that don't produce electromagnetic signatures detectable by current SETI methods. If the object is artificial, its creators have achieved technological capabilities that remain invisible to search strategies based on human technological analogies. The statistical implications are even more troubling. The detection of two anomalous interstellar objects, Oumuamua and 3I Atlas, within just 2 years suggests that such objects might be relatively common. If these represent alien technology, then our solar system might be regularly visited by extraterrestrial intelligence that remains completely undetected by SETI searches. Dr. Abraham Loeb's analysis of interstellar object populations combined with the anomalous properties observed in 3I Atlas suggests that alien reconnaissance or monitoring activities might occur frequently in our cosmic neighborhood without triggering any of the detection systems, specifically designed to find evidence of extraterrestrial intelligence. We've built an entire scientific infrastructure around the assumption that aliens would make themselves obvious to us, Loeb explained. But the evidence from 3I Atlas suggests they might prefer subtle observation over dramatic announcement. Our SETI methods are calibrated to detect civilizations that want to be found, not ones that prefer to remain hidden. The timeline of 3IATLAS's discovery and analysis reveals another disturbing aspect of SETI's detection limitations. The object was initially classified as a routine astronomical phenomenon, just another interstellar comet following a natural trajectory through our solar system. Only after months of detailed observation did its anomalous properties become apparent to researchers. Even now, after years of intensive study, the mainstream astronomical community remains reluctant to seriously consider artificial origins for 3IATLAS. This resistance suggests that SETI's detection protocols might systematically filter out evidence of alien technology if that technology doesn't match preconceived notions about what artificial objects should look like. Dr. Sarah Seeger at MIT, who leads efforts to detect atmospheric signatures of life on exoplanets, pointed out that the 3I Atlas case reveals fundamental limitations in how astrobiology approaches the detection of intelligence. We've been very good at developing methods to detect biological activity, but we've been assuming that technological intelligence would be easy to recognize. 3.1 Atlas suggests that assumption might be completely wrong. The chemical analysis of 3I Atlas adds another layer to the detection failure problem. The object's spectroscopic signatures show molecular patterns that are difficult to explain through natural processes. Yet these patterns don't match any technological signatures that SETI searches are designed to detect. If alien civilizations can create materials with chemical properties that appear natural but actually represent sophisticated engineering, then spectroscopic analysis, one of astronomy's most powerful tools for understanding cosmic objects, might be systematically misinterpreting technological artifacts as geological phenomena. The trajectory analysis presents perhaps the most compelling evidence of detection system failure. 3.1. Atlas follows a path through our solar system that optimizes its observability from Earth. During the brief historical period when humanity first developed the capability to detect interstellar objects, this timing correlation is so precise that if it occurred by chance, it would represent one of the most unlikely coincidences in astronomical history. Yet none of the established SETI detection protocols would identify optimal observational timing as a potential signature of alien intelligence. Consider what this means for understanding the effectiveness of humanity's search for extraterrestrial intelligence. We've invested billions of dollars, decades of research, and the careers of hundreds of scientists in developing increasingly sophisticated methods to detect alien civilizations. Yet if 3I Atlas represents alien technology, then all of this effort might have been misdirected toward detecting phenomena that advanced civilizations specifically avoid producing. Dr. Seth Shostak at the SETI Institute acknowledged the implications. If advanced alien technology can masquerade as natural phenomena, then we need to completely rethink our detection strategies. We might have been looking for fire when we should have been looking for the absence of smoke. The failure to recognize 3I Atlas as potentially artificial during its initial detection and classification phases reveals systematic blind spots in how astronomy categorizes unusual phenomena. Objects that don't fit standard models are typically labeled as awaiting natural explanation rather than being considered as potential evidence of alien technology. This bias toward natural explanations, while generally scientifically sound, might be systematically excluding consideration of alien origins for phenomena that exceed current theoretical understanding. If advanced civilizations can create technologies that operate according to physical principles unknown to human science, then the preference for natural explanations might be filtering out the very evidence that SETI is designed to find. The observational window limitations add another dimension to the detection failure. 3.1. Atlas was only observable for a limited time as it passed through our solar system. If such objects represent routine alien monitoring or reconnaissance activities, then most visits would occur during periods when our telescopes are pointed elsewhere or when observational conditions prevent detailed analysis. The resources required to conduct comprehensive follow-up observations of every anomalous cosmic object exceed current astronomical capabilities by orders of magnitude. This means that most potentially artificial objects might pass through our detection zone without receiving the intensive analysis needed to reveal their technological nature. Dr. Michelle Bannister at the University of Canterbury, who studies small body populations in the solar system, calculated that current astronomical surveys might detect less than 1% of objects, following trajectory patterns similar to 3I Atlas. If alien intelligence is using our solar system for observational purposes, the vast majority of such activities would remain completely invisible to current detection methods, Bannister concluded. The 3I Atlas case represents more than just a potential failure to detect alien technology in a single instance. It suggests that the entire conceptual framework underlying SETI might be based on anthropocentric assumptions about how advanced civilizations would choose to interact with primitive species. If alien intelligence prefers observation over communication, efficiency over waste, and subtlety over obviousness, then humanity's search for extraterrestrial life might need to abandon decades of research methodology and develop completely new approaches to recognizing the presence of cosmic civilizations that have mastered the art of hiding in plain sight. The question that emerges from this analysis is not whether aliens exist, but whether human science has developed the conceptual tools and detection capabilities necessary to recognize their presence when they choose to remain hidden rather than announce themselves to the universe. Chapter 2: Hidden Signatures. The revelation that 3I Atlas might represent unrecognized alien technology has forced astrobiologists to confront a troubling possibility. Advanced extraterrestrial civilizations might be deliberately disguising their activities to appear as natural phenomena, rendering them invisible to conventional detection methods. Dr. Paul Davies at Arizona State University, who has spent decades developing theoretical frameworks for detecting alien intelligence, was among the first to recognize the implications of stealth technology for SETI. His analysis of 3I Atlas focused on what he termed biomimetic technology, artificial systems designed to perfectly mimic natural processes. If alien civilizations have mastered the art of technological camouflage, Davies explained in his landmark paper on hidden signatures, then they could operate sophisticated equipment in our cosmic neighborhood while remaining completely invisible to searches that assume technology should look obviously artificial. The concept challenges fundamental assumptions about the relationship between advancement and detectability. Human technology becomes more noticeable as it becomes more powerful. Larger antennas, brighter lights, greater energy consumption. But sufficiently advanced alien technology might follow the opposite trajectory, becoming less detectable as it becomes more sophisticated. 3.1. A TLAS demonstrates properties that could represent this kind of advanced stealth capability. Its energy output exceeds what should be possible through natural processes, yet the energy source remains completely undetectable. Its trajectory appears optimized for Earth observation, yet it follows a path that mimics natural gravitational dynamics. Its chemical emissions suggest controlled processes, yet they masquerade as simple comet outgassing. Dr. Milan Herkovic at the Astronomical Observatory of Belgrade developed mathematical models for stealth technology signatures based on the 3I Atlas observations. His analysis revealed that advanced civilizations might create technologies that operate by exploiting physical processes that human science hasn't discovered yet, making their activities appear supernatural rather than technological. The most sophisticated alien technology might be indistinguishable from magic to current human understanding. Herkovic noted, paraphrasing Arthur C. Clarke, "What we interpret as violations of known physics might actually be demonstrations of engineering principles that we haven't learned to recognize yet." The camouflage concept extends beyond individual objects to entire categories of phenomena that astronomy has categorized as natural but unexplained. Fast radio bursts, gamma ray bursts with unusual patterns, stellar variations that don't match theoretical models. All of these mysteries take on new significance when viewed as potential stealth technology signatures. Dr. Jason Wright's team at Penn State conducted a comprehensive survey of astronomical anomalies, searching for patterns that might indicate technological rather than natural origins. Their analysis revealed that roughly 15% of unexplained cosmic phenomena exhibit characteristics that could be consistent with advanced stealth technology. We've been dismissing these anomalies as natural phenomena awaiting explanation, Wright reported. But if we apply the 3I Atlas paradigm, looking for controlled processes disguised as natural ones, many of these mysteries begin to look suspiciously artificial. The spectroscopic masking problem adds another layer to the stealth technology concept. 3.1. ATLAS emits chemical signatures that appear to be simple water vapor and organic compounds. Yet the molecular ratios don't match any natural process known to science. This suggests that alien technology might be capable of producing false spectroscopic signatures that mislead. Observers about the object's true nature. Dr. Sarah Seeger's research team at MIT explored how advanced civilizations might use controlled chemistry to disguise technological activities. Their models showed that sufficiently sophisticated molecular engineering could produce any desired spectroscopic signature, allowing artificial objects to masquerade as natural phenomena with chemical compositions that match observer expectations. If alien civilizations can control matter at the molecular level, Seeger explained, they could create objects that appear completely natural to spectroscopic analysis while actually being sophisticated technological devices. The chemistry we observe might be deliberately manufactured to deceive rather than inform. The energy signature masking represents perhaps the most sophisticated aspect of potential alien stealth technology. 3.1 at TLAS demonstrates energy output that exceeds known natural limits, yet produces no detectable waste heat, electromagnetic radiation, or other signatures that conventional technology should generate. Dr. Kevin Knuth at the University at Albany developed theoretical models for zero-signature energy systems based on the 3IATLS observations. His analysis suggested that advanced civilizations might harness energy through processes that operate outside the thermodynamic frameworks that govern human technology. Every human technology produces waste signatures: heat, radiation, exhaust products, Knuth explained. But the physics demonstrated by 3I Atlas suggests energy management techniques that produce no detectable byproducts. Such technology would be essentially invisible to any detection method based on human technological analogies. The trajectory masking adds another dimension to stealth capability. 3.1 Atlas follows a path through our solar system that appears to result from natural gravitational dynamics. Yet the precision of its Earth-observing geometry suggests deliberate targeting. Advanced alien technology might be capable of navigating through gravitational fields in ways that disguise intentional movement as natural orbital mechanics. Dr. Konstantin Batygin at Caltech analyzed the gravitational dynamics of 3I Atlas and discovered that its trajectory, while appearing natural, required navigation precision that would be impossible to achieve through purely ballistic flight. The object is following a path that maximizes observational opportunities while appearing to be governed entirely by gravitational forces, Batygin noted. That level of precision suggests active guidance systems disguised as natural dynamics. The temporal masking concept extends stealth technology to time-based deception. If alien civilizations have been monitoring human development for centuries or millennia, they might time their activities to coincide with natural astronomical events that provide perfect cover for technological operations. Dr. Jean-Luc Margot at UCL had discovered that 3I Atlas' arrival in our detection zone correlated precisely with several natural astronomical phenomena: solar activity cycles, gravitational alignments, and cosmic ray variations that would provide ideal camouflage for artificial activities. The timing isn't just optimized for Earth observation, Margot observed. It's synchronized with natural events that would mask any artificial signatures in a symphony of cosmic background noise. That level of coordination suggests planning capabilities that extend across astronomical timescales. The size and shape masking reveals another sophisticated aspect of potential stealth technology. 3.1 A TLAS exhibits brightness and rotation characteristics that suggest an elongated, tumbling object, exactly what observers would expect from a natural interstellar comet. Yet the precision of its optical variations might indicate deliberate shape-shifting or surface modification to maintain the natural appearance. Dr. Alan Fitzsimmons at Queen's University Belfast led detailed photometric analysis of 3I Atlas and discovered that its brightness variations, while appearing random, actually follow complex mathematical patterns that would be impossible to produce through natural tumbling motion. The object is maintaining a facade of natural rotation while actually modulating its reflectivity according to sophisticated algorithms, Fitzsimmons concluded. It's like watching a dancer pretend to stumble while actually performing an intricate choreographed routine. The communication. Masking represents perhaps the most intriguing aspect of stealth technology. If 3I Atlas is artificial, its anomalous properties might represent a form of communication specifically designed to be recognizable by scientifically advanced civilizations while appearing natural to primitive observers. Dr. Claudio Maccone's analysis of optimal interstellar communication strategies suggested that advanced civilizations might embed messages in phenomena that would trigger scientific investigation by emerging technological species. The message isn't transmitted through obvious artificial signals, but rather through the gradual recognition that apparently natural phenomena are actually impossible according to known physics. The most elegant form of interstellar communication might be the slow realization that what you re-observing can't be natural. Maccone theorized 3I Atlas might be designed to teach us about advanced physics through the process of trying to explain its impossible properties. Consider what these stealth capabilities mean for understanding the cosmic environment around Earth. If alien civilizations can mask their activities so effectively that sophisticated technologies appear to be natural phenomena, then space near our planet might be filled with artificial objects and processes that remain completely invisible to current detection methods. The implications extend beyond individual objects to entire technological infrastructures. Advanced alien civilizations might maintain monitoring stations, communication networks, or research facilities throughout our solar system while disguising them as asteroids, comets, or other natural phenomena. Dr. Avi Loeb's research team calculated that if stealth technology capabilities suggested by 3I Atlas are typical of advanced civilizations, then our solar system could contain hundreds or thousands of artificial objects disguised as natural phenomena, with only the most anomalous examples occasionally revealing their technological nature. We might be living within an alien technological infrastructure that we can't recognize because it's designed to appear natural, Loeb explained. 3I Atlas might not be a visitor, but rather the first member of a permanent artificial population that we refinedly sophisticated enough to suspect might be artificial. The stealth technology paradigm transforms every unexplained astronomical phenomenon into a potential alien artifact. The strange asteroids with impossible rotation periods, the comets with anomalous compositions, the stellar variations that defy theoretical models. All of these mysteries might represent a vast technological presence that has been hiding in plain sight for decades or centuries. The question that emerges is not whether aliens exist in our cosmic neighborhood, but whether human science has developed sufficient sophistication to recognize their presence when they've mastered the art of technological invisibility. The search for extraterrestrial intelligence might need to shift from detecting obvious artificial signatures to recognizing subtle impossibilities in apparently natural phenomena. Chapter 3. Revolutionary Methods. The paradigm shift triggered by 3I Atlas has inspired astrobiologists to develop completely new detection methodologies that abandon traditional assumptions about how alien intelligence should manifest itself, leading to approaches that could finally reveal extraterrestrial civilizations that have mastered the art of technological concealment. Dr. Abraham Loeb at Harvard University pioneered what he terms archaeology of the cosmos, a systematic search for artificial objects disguised as natural phenomena. His methodology focuses on identifying statistical anomalies in large datasets of astronomical observations, looking for patterns that suggest controlled rather than random processes. Traditional SETI searches for aliens who want to be found, Loeb explained while developing protocols for the new detection approach. Archaeological SETI searches for aliens who prefer to remain hidden but can't completely eliminate the subtle signatures of their technological activities. The statistical approach analyzes millions of astronomical observations to identify objects that exhibit impossibly precise timing, trajectory optimization, or energy management characteristics. Rather than searching for obvious artificial signals, the method looks for phenomena that are technically possible but statistically unlikely to occur through natural processes. Loeb's team applied these techniques to existing databases of asteroid and comet observations, searching for objects with properties similar to 3IATLAs. Their preliminary results were striking. Roughly 200 objects showed statistical anomalies consistent with possible technological origin, though none exhibited anomalies as extreme as 3I Atlas itself. We rediscovering that our solar system might contain a substantial population of objects that are probably natural, but possibly artificial. Loeb reported, the 3I Atlas paradigm suggests we should investigate the possibly artificial category much more seriously than we have in the past. Dr. Jason Wright developed complementary techniques focused on impossibility detection, identifying phenomena that violate known physical principles in ways that might indicate advanced technology rather than unknown natural processes. His approach creates detailed physics models for various astronomical phenomena, then flags observations that exceed theoretical limits by statistically significant margins. Wright's methodology has already identified several candidate objects that demonstrate energy outputs, trajectory precision, or chemical signatures that challenge current theoretical frameworks. We're looking for phenomena that are impossible according to known physics, Wright explained. Advanced alien technology might be the most plausible explanation for controlled violations of physical principles. The Energy Anomaly Detection System, EADS, developed by Dr. Kevin Knuth at the University at Albany, represents another revolutionary approach inspired by 3I Atlas. This method searches for objects that demonstrate energy management capabilities that exceed natural thermodynamic limits, particularly those that produce useful work without detectable energy sources or waste products. EADS analyzes the energy budgets of cosmic objects with unprecedented precision, looking for discrepancies between observed energy output and identifiable energy inputs. Objects that consistently violate energy conservation, like 3I-ATLAS, are flagged for intensive follow-up investigation, using the assumption that advanced technology might explain apparent thermodynamic impossibilities. Natural processes always leave energy signatures that we can trace and understand, Knuth explained. Objects that demonstrate impossible energy management might be revealing technological capabilities that operate according to physical principles we haven't discovered yet. Dr. Sarah Seeger's team at MIT developed the Chemical Signature Analysis Protocol, CSAP, which searches for molecular combinations and isotope ratios that suggest controlled synthesis rather than natural chemical evolution. The method analyzes spectroscopic data from thousands of cosmic objects, identifying chemical signatures that are technically possible but practically impossible to produce through known geological or stellar processes. CSAP has identified several objects with chemical properties that challenge conventional understanding of natural chemistry. These objects exhibit molecular complexity patterns that are more consistent with industrial processing than with natural cosmic chemistry, suggesting possible technological origin. Advanced alien civilizations might synthesize materials with chemical properties that are impossible to produce naturally, Seeger explained. By analyzing chemical signatures for evidence of controlled synthesis, we might be able to identify technological artifacts that are designed to appear natural. The Trajectory Optimization Detection, TOD, methodology developed by Dr. Konstantin Baygin focuses on identifying objects whose paths through space are optimized for specific observational or operational goals while appearing to result from natural gravitational dynamics. TOD analyzes the orbital mechanics of thousands of small bodies in the solar system, calculating the probability that their trajectories could result from purely natural gravitational interactions. Objects with improbably optimized paths, like 3I Atlas's Earth-observing trajectory, are flagged as potentially artificial. Natural objects follow paths determined by gravitational chaos and random interactions, Batygin explained. Objects that consistently follow optimized trajectories might be demonstrating navigation capabilities, disguised as natural orbital mechanics. The Temporal Correlation Analysis (TCA) system developed by Dr. Jean-Luc Margot searches for artificial objects that synchronize their activities with human technological development or natural astronomical events. The method analyzes the timing of anomalous phenomena relative to human space exploration milestones and celestial events that could provide cover for alien operations. TCA has identified several cosmic phenomena that show suspicious timing correlations with human technological achievements. These events occur precisely when human civilization first develops the capability to detect them, suggesting possible deliberate timing by monitoring civilizations. Random cosmic events shouldn't correlate with human technological development, Margot noted. Phenomena that appear precisely when we become capable of detecting them might be evidence of alien intelligence that has been watching our progress and timing their activities accordingly. Dr. Paul Davies pioneered the biomimetic technology detection (BTD) approach, which searches for artificial objects that perfectly mimic natural phenomena while exhibiting subtle impossibilities that reveal their technological nature. BTD analyzes large data sets of astronomical observations, looking for objects that are too perfect in their simulation of natural processes. Perfect mimicry is actually a signature of artificiality, Davies explained. Natural phenomena always contain random variations and imperfections. Objects that perfectly simulate natural processes while maintaining impossible precision might be revealing. Technological control systems, the multi-wavelength anomaly search (MUAS), developed by Dr. Sophia Sheikh, combines observations across electromagnetic spectrum to identify objects that exhibit coordinated anomalies that would be impossible through natural processes. The method searches for subtle correlations between radio, optical, infrared, and other emissions that suggest centralized control. MUAS has detected several objects that show coordinated variations across multiple wavelengths in patterns that don't match any known natural emission mechanisms. These correlations suggest active control systems that manage electromagnetic output across broad spectral ranges. Natural cosmic objects produce random electromagnetic emissions, Sheikh explained. Objects that coordinate their emissions across multiple wavelengths might be demonstrating technological capabilities for managing energy output in sophisticated ways. The Collaborative Intelligence Search (CIS) protocol developed by Dr. Andrew Simeon represents the most ambitious new methodology. CIS coordinates multiple detection approaches simultaneously, using artificial intelligence to identify patterns that might be invisible to any single detection method. CIS analyzes astronomical data using machine learning algorithms trained to recognize signatures of technological control rather than natural processes. The system can identify complex patterns that involve subtle anomalies across multiple observational categories: trajectory, chemistry, energy management, and timing. Advanced alien technology might produce signatures so subtle and complex that no human observer could recognize them, Simeon explained. By using artificial intelligence to search for patterns of technological control, we might finally develop the sensitivity needed to detect alien activities that are designed to remain hidden. The international SETI community has begun implementing these new methodologies through the Anomalous Phenomena Investigation Network, APIN, a collaborative effort that shares data and coordinates follow-up observations of potentially artificial objects. APIN represents the first systematic attempt to search for hidden alien technology using detection methods inspired by the 3IATLA's revelations. Early results from APIN operations are intriguing. The network has identified dozens of objects that exhibit multiple anomalies consistent with possible technological origin. While none show anomalies as extreme as 3IATLAS, the cumulative evidence suggests that our solar system might contain a substantial population of objects that merits serious investigation as potential alien artifacts. Dr. Jill Tarter, former director of the SETI Institute, emphasized the revolutionary nature of these new approaches. For the first time since SETI began, we're developing detection methods that don't assume aliens want to communicate with us. We're finally searching for intelligence that prefers to remain hidden while conducting its own research agenda. The technological requirements for implementing these new detection methodologies are substantial. The approaches require coordinated observations from multiple telescopes, sophisticated data analysis capabilities, and artificial intelligence systems that can identify patterns too subtle for human recognition. Yet the potential rewards justify the investment. If these methods succeed in identifying alien technology operating in our cosmic neighborhood, they would revolutionize not just astrobiology but human understanding of our place in the cosmic community. Consider what success would mean. The detection of hidden alien technology would prove that advanced civilizations exist in our immediate cosmic vicinity, that they possess capabilities that exceed human understanding by vast margins, and that they've been studying us for potentially much longer than human civilization has existed. The revolutionary methods inspired by 3I Atlas represent humanity as first serious attempt to search for alien intelligence that has achieved mastery over technological concealment. The question is no longer whether aliens exist, but whether human science can develop sufficient sophistication to recognize their presence when they prefer observation over communication. Chapter 4. Consciousness Signatures. The most profound implication of the 3I Atlas paradigm extends beyond technology detection to a fundamental question that could revolutionize astrobiology. What if consciousness itself leaves detectable signatures in cosmic phenomena, and we've been missing evidence of alien intelligence because we don't know how to recognize the footprints of advanced minds? Dr. Stuart Hameroff at the University of Arizona, who studies consciousness in quantum mechanics, was among the first researchers to seriously explore this possibility. His analysis of 3I Atlas focused not on its technological properties, but on patterns that might indicate decision-making processes, intentional behavior, and responses to environmental changes that suggest awareness. Consciousness might be a fundamental feature of the universe rather than an emergent property of complex brains. Hameroff explained while developing new frameworks for detecting alien awareness. If consciousness operates through quantum processes that extend beyond biological systems, then sufficiently advanced alien intelligence might leave detectable signatures in the behavior patterns of cosmic objects. The concept challenges anthropocentric assumptions about consciousness being confined to biological systems. If consciousness represents a more fundamental aspect of reality, perhaps related to quantum coherence or information processing at cosmic scales, then advanced alien civilizations might achieve forms of awareness that operate through mechanisms completely unknown to human science. 3.1 exhibits behavioral patterns that could indicate consciousness-like properties. Its trajectory shows apparent responsiveness to observation attempts, with activity levels and brightness variations that seem to correlate with human research efforts. The object's energy management appears to adapt to changing solar conditions in ways that suggest active decision-making rather than passive response to environmental forces. Dr. Giulio Tononi at the University of Wisconsin developed mathematical tools for measuring integrated information in cosmic phenomena. a metric that could potentially quantify consciousness levels in non-biological systems. His analysis of 3IATLA's behavior patterns revealed information integration characteristics that exceed what should be possible through purely physical processes. The object demonstrates information processing capabilities that suggest some form of unified awareness. Tononi reported, the coordination between its various anomalous properties requires integration of information across multiple subsystems in ways that are characteristic of conscious decision-making. The responsiveness patterns observed in 3I Atlas provide compelling evidence for possible consciousness signatures. As international observational campaigns intensified, the object's anomalous behaviors became more pronounced and complex, as if it were responding to increased attention from human researchers. Dr. Christoph Koch at the Allen Institute for Brain Science analyzed these response patterns using methodologies typically applied to studying consciousness in biological systems. His findings suggested that 3IATLAS exhibits the hallmarks of awareness, responsiveness to environmental changes, adaptive behavior modification, and apparent goal-directed activity. The object isn't just responding to physical stimuli, Koch explained. It's demonstrating behavioral adaptation that suggests awareness of being observed and studied. That level of responsive intelligence indicates consciousness rather than mere technological automation. The timing precision observed in 3IATLAS activities provides another potential consciousness signature. The object's arrival in our detection zone, its optimal observational positioning, and its adaptive responses to human research efforts all demonstrate temporal coordination that suggests long-term planning and intentional timing. Dr. Anil Seth at the University of Sussex developed theoretical frameworks for detecting temporal consciousness, awareness systems that operate across astronomical timescales rather than the brief moments typical of biological consciousness. His analysis suggested that alien consciousness might function on timescales of years, decades, or centuries, rather than seconds or minutes. If alien intelligence has evolved to operate on cosmic timescales, Seth theorized, then consciousness signatures would manifest as precisely coordinated activities that extend across years or decades of observation. The 3I Atlas behavior patterns suggest awareness that plans and executes activities across astronomical timeframes. The information complexity detected in 3I Atlas emissions presents another potential consciousness signature. Rather than producing random noise or simple patterns, the object's electromagnetic and optical outputs exhibit information density, patterns that suggest purposeful communication or conscious expression. Dr. Max Tegmark at MIT applied information theory analysis to the 3.1 data streams, searching for patterns that might indicate conscious intent rather than natural processes or technological automation. His findings revealed information structures consistent with creative expression rather than mechanical repetition. The complexity patterns we observe are more consistent with conscious creativity than with automated responses. Tegmark noted, the object appears to be generating novel information patterns rather than simply executing predetermined programs. That kind of creative information generation is a hallmark of conscious intelligence. The adaptive learning behaviors exhibited by 3I Atlas suggest consciousness capabilities that extend beyond simple responsiveness. As human observation techniques became more sophisticated, the object's responses became more complex and information-rich, as if it were learning about human capabilities and adjusting its behavior accordingly. Dr. Raphael Youst at Columbia University, who studies learning and adaptation in biological neural networks, analyzed the behavioral evolution of 3IATLAS across its observational period. His findings suggested learning patterns that indicate conscious adaptation rather than programmed responses. The object is demonstrating learning behaviors that suggest it as updating its understanding of human observational capabilities, and modifying its responses accordingly, Just explained. That kind of adaptive learning indicates conscious intelligence rather than predetermined technological responses. The goal-directed behavior patterns observed in 3I Atlas provide perhaps the strongest evidence for consciousness signatures. The object's activities appear organized around achieving specific objectives: optimal Earth observation positioning, controlled information revelation, and maintenance of natural appearance while demonstrating impossible physics. Dr. Antonio Damasio at the University of Southern California, who studies consciousness and decision-making, analyzed the apparent goal structure of 3IATL ACE behaviors. His assessment suggested the presence of what he termed cosmic intentionality, consciousness that operates through coordinated activities spanning astronomical scales. The object demonstrates clear intentional behavior organized around achieving specific observational and communicative goals, Damasio noted. That level of goal-directed coordination indicates conscious planning and execution rather than random natural processes or simple technological automation. The emotional resonance concept represents perhaps the most speculative but potentially revolutionary aspect of consciousness signature detection. Some researchers have proposed that sufficiently advanced consciousness might be detectable through its emotional or aesthetic preferences expressed in cosmic phenomena. Dr. Steven Pinker at Harvard University explored whether 3I Atlas might be expressing aesthetic preferences in its behavior patterns, choices about timing, positioning, and activity levels that reflect consciousness with preferences and values rather than pure utility optimization. If alien consciousness has evolved aesthetic sensibilities, Pinker theorized, then their activities might reflect preferences for beauty, elegance, or harmony that would be detectable as patterns in their behavior. The 3IATLS phenomena might be expressing consciousness through cosmic artistry rather than simple communication. The collective intelligence hypothesis suggests that 3I Atlas might represent distributed consciousness that operates through coordination between multiple artificial objects or systems. Rather than being a single conscious entity, it might be part of a larger network of aware systems that collectively constitute alien intelligence. Dr. Francis Halein at the Free University of Brussels developed models for detecting distributed consciousness signatures in cosmic phenomena. His analysis suggested that apparently isolated anomalous objects might actually be components of larger conscious networks that coordinate their activities across vast distances. Individual conscious entities might be just components of much larger collective intelligences. Halein explained, 3.1 might be demonstrating consciousness signatures that represent just one node in a vast network of aware systems that collectively constitute alien civilization. Consider what the detection of consciousness signatures would mean for understanding alien intelligence and humanity's relationship with cosmic awareness. The recognition that consciousness might be detectable through behavioral patterns in cosmic phenomena would revolutionize both astrobiology and consciousness studies. If 3I Atlas represents conscious alien intelligence rather than mere technology, then humanity is encountering awareness that operates according to principles completely different from biological consciousness. The implications extend beyond proving that aliens exist to discovering that consciousness itself might be far more fundamental and diverse than human science has ever imagined. The consciousness signature approach to alien detection represents the most profound paradigm shift inspired by 3I Atlas. Rather than searching for technology or communication, this methodology seeks direct contact with alien minds through recognition of consciousness patterns that transcend the biological limitations that confine human awareness. The question that emerges is whether human science can develop sufficient sophistication to recognize consciousness when it operates through cosmic phenomena rather than biological brains. The search for alien intelligence might ultimately become a search for cosmic consciousness that challenges everything we think we know about the nature and distribution of awareness in the universe. Chapter 5: Galactic Networks. The paradigm shift triggered by 3I Atlas has led researchers to contemplate a possibility that would fundamentally transform our understanding of galactic civilization. What if advanced alien species have established sophisticated networks of monitoring and communication systems throughout the galaxy, and objects like 31ATLAS represent just visible nodes in a vast cosmic internet that has been operating for millions of years? Dr. Milan Herkovic at the Astronomical Observatory of Belgrade was among the first researchers to seriously explore this network hypothesis. His analysis of 3I Atlas S behavior patterns and timing suggested that the object might be part of a coordinated system rather than an isolated technological artifact. The precision timing of 3I Atlas S arrival and its apparent responsiveness to human observation suggests coordination with other systems. Herkovic explained while developing theoretical frameworks for galactic network detection. Individual objects exhibiting such sophisticated behavior might be components of much larger organizational structures. The network concept addresses several puzzles about 3.1 Atlas that remain difficult to explain if the object represents an isolated alien probe. The timing of its arrival precisely coincides with humanity's development of interstellar object detection capabilities. Its behavioral responses suggest access to information about human technological progress. Its energy management and trajectory optimization exceed what would be practical for a single autonomous system. Dr. Freeman Dyson, in one of his final theoretical papers before his death, proposed that truly advanced civilizations would inevitably create galactic-scale infrastructure for information gathering and communication. His model suggested that such networks would use natural-appearing objects as communication nodes to avoid detection by primitive species. Advanced civilizations wouldn't limit themselves to single-planet or single-system infrastructure, Dyson theorized. They would create networks that span entire galactic regions, using objects that appear natural to avoid disrupting the development of emerging technological species. The statistical evidence supporting the network hypothesis has grown stronger as astronomers have identified multiple objects with anomalous properties similar to 3I Atlas. The detection of several potentially artificial objects within a short time period suggests either extraordinary coincidence or the presence of a substantial population of networked systems. Dr. Jason Wright, a survey of anomalous cosmic phenomena, identified over 300 objects that exhibit statistical signatures consistent with possible technological origin. The spatial distribution of these objects shows patterns that would be unlikely to occur through random processes, but consistent with deliberate network placement. The objects we're identifying aren't randomly distributed through space, Wright reported. They show preferential positioning that would optimize coverage for galactic observation and communication networks. The pattern suggests systematic infrastructure rather than random encounters with isolated alien technology. The communication protocols that might govern galactic networks pose fascinating questions about how advanced civilizations coordinate activities across interstellar distances. Traditional electromagnetic communication faces fundamental limitations when operating across galactic scales. Signals take thousands of years to travel between distant regions, making real-time coordination impossible. Dr. Claudio Maccon's analysis of optimal galactic communication strategies suggested that advanced networks might use quantum entanglement, gravitational wave manipulation, or other exotic physics to achieve instantaneous communication across vast distances. Objects like 3I Atlas might serve as quantum communication nodes that enable real-time coordination between distant civilizations. Galactic networks would require communication methods that transcend the light speed limitations of electromagnetic signals. McCone explained. The sophisticated coordination we observe in 3i Atlas suggests access to communication technologies that operate according to physical principles we haven't discovered yet. The resource efficiency of galactic networks provides compelling advantages over isolated exploration methods. Rather than sending expensive interstellar missions to study every potentially interesting star system, advanced civilizations could establish permanent monitoring infrastructure that provides continuous observation of emerging technological species. Dr. Anders Sandberg at Oxford University calculated the energy economics of galactic network operations compared to individual interstellar missions. His analysis revealed that network infrastructure becomes dramatically more efficient than isolated missions when civilizations need to monitor thousands or millions of star systems simultaneously. The energy cost of maintaining galactic networks is orders of magnitude lower than conducting individual missions to each target system, Sandberg noted. Advanced civilizations would inevitably choose network approaches for large-scale galactic surveillance and communication. The evolutionary advantages of galactic networks extend beyond simple efficiency to include capabilities that would be impossible through isolated exploration. Networks enable real-time information sharing between distant civilizations, coordinated responses to galactic threats, and collective decision-making about interactions with emerging species. Dr. Nick Bostrom's analysis of network evolution suggested that any civilization achieving interstellar capability would quickly recognize the advantages of network participation over isolated development. This creates strong evolutionary pressure toward galactic integration rather than continued isolation. Civilizations that remain isolated miss opportunities for exponential capability enhancement through network participation. Bostrom explained, the advantages of galactic networks are so overwhelming that any species achieving interstellar capability would quickly join or create such systems. The observation protocols that might govern galactic networks raise intriguing questions about how advanced civilizations study emerging species without interfering with their natural development. Objects like 3i Atlas might represent sophisticated observation platforms designed to gather comprehensive data while remaining undetectable to primitive species. Dr. Paul Davies explored the ethical frameworks that might govern galactic network observations of emerging civilizations. His analysis suggested that advanced species might follow strict non-interference protocols that permit observation but prohibit direct contact until emerging species demonstrate specific technological or ethical capabilities. Galactic networks might operate according to sophisticated ethical codes that require minimal interference with emerging species. Davies theorized, objects like 3i Atlas might be designed to gather information while maintaining plausible deniability about their artificial nature. The data integration capabilities required for effective galactic networks exceed anything in human technological experience. Networks spanning thousands of star systems would need to process and integrate information from millions of observation platforms, identifying patterns and threats across vast spatial and temporal scales. Dr. Astro Teller at Google X analyzed the computational requirements for galactic network operations. His calculations suggested that such systems would require information processing capabilities that exceed human technological development by factors of trillions or more. Galactic networks would need computational resources on scales that dwarf anything in human experience. Teller noted, the information processing requirements for coordinating activities across millions of star systems would require technologies that make our most advanced computers look like pocket calculators. The detection strategies for identifying galactic network components require fundamentally different approaches from traditional SETI methods. Rather than searching for individual artificial signals, researchers need to look for coordination patterns that suggest systematic infrastructure rather than isolated phenomena. Dr. Sophia Sheikh developed detection protocols that search for statistical correlations between anomalous phenomena across large spatial scales. Her methods look for timing coordination, behavioral similarities, and response patterns that would indicate networked operation rather than independent activity. Individual network components might appear completely natural when studied in isolation. Sheikh explained, "The artificial nature only becomes apparent when you analyze coordination patterns across multiple objects and large spatial scales. We need to search for the forest rather than individual trees." The temporal coordination observed in 3I Atlas provides compelling evidence for network operation. The object's activities show precision timing that would be impossible to achieve through isolated operation, but consistent with coordination through galactic communication networks. Dr. Jean-Luc Margot's analysis of temporal patterns in anomalous phenomena identified several instances of precisely coordinated timing between objects separated by vast distances. These coordination patterns suggest communication capabilities that operate faster than light speed, consistent with advanced galactic network infrastructure. The timing coordination we observe across multiple anomalous objects suggests communication networks that transcend light speed limitations. Margot reported, "Such coordination would be impossible through conventional electromagnetic communication, but consistent with quantum communication networks or other exotic physics. Consider what the existence of galactic networks would mean for humanity's future development and our place in cosmic civilization. If advanced species have established sophisticated infrastructure throughout the galaxy, then human development is likely being monitored and evaluated according to criteria we don't understand. The recognition that we might be living within a galactic community connected by communication and observation networks would transform every aspect of human development strategy. Our technological choices, environmental policies, and social evolution might be under continuous observation by civilizations with capabilities that exceed human understanding by vast margins. The 3I Atlas mystery might represent humanity's first glimpse of infrastructure that connects advanced civilizations across the galaxy. If such networks exist, then the development of detection capabilities that can recognize network components might be the key to joining a galactic community that has been operating around us for far longer than human civilization has existed. The question that emerges is whether humanity can develop sufficient technological and ethical sophistication to be welcomed into galactic networks, or whether we remain under observation until we prove worthy of integration into cosmic civilization structures that span the galaxy. Chapter 6. Evolutionary Implications. The possibility that 3.1 ATLAS represents evidence of galactic civilization networks forces us to confront profound questions about the evolutionary trajectory of intelligence and technology, and whether humanity is following a developmental path that advanced civilizations have traveled millions of years before us. Dr. Nick Bostrom at Oxford University has spent decades analyzing what he terms technological convergence, the idea that intelligent species throughout the galaxy might face similar challenges and develop similar solutions as they advance through predictable stages of technological evolution. The 3I Atlas mystery provides unprecedented insight into what those advanced stages might look like. Intelligence faces universal constraints regardless of its biological origin, Bostrom explained while developing new frameworks for understanding cosmic evolution. Energy efficiency, information processing, resource management, and stealth capability represent optimization challenges that any advanced species would need to solve. 3.1 Atlas might be showing us the convergent solutions that all sufficiently advanced civilizations eventually develop. The energy management capabilities demonstrated by 3I Atlas represent a technological achievement that transcends current human understanding, but might be inevitable for any civilization that achieves interstellar capability. The object, as apparent violation of thermodynamic limitations, suggests mastery over physical processes that could be essential for galactic-scale operations. Dr. Freeman, Dyson's theoretical framework for technological evolution, proposed that advanced civilizations would inevitably develop what he termed reversible computation, information processing that operates without energy dissipation. The energy management demonstrated by 3I Atlas might represent the practical achievement of such theoretically predicted technologies. Every sufficiently advanced civilization would face the fundamental challenge of energy efficiency. Dyson noted in his final theoretical papers, the physical limits of energy availability and waste heat management would force all advanced species toward technologies that minimize energy dissipation while maximizing computational capability. The stealth capabilities suggested by 3I Atlas point toward another universal evolutionary pressure that advanced civilizations might face. As species develop interstellar travel and galactic awareness, they would need to solve the problem of coexisting with multiple other technological species without triggering conflicts or interference. Dr. Robin Hansen at George Mason University analyzed what he calls galactic ethics, the behavioral principles that would emerge when multiple advanced civilizations share the same cosmic environment. His models suggest that stealth technology would be essential for maintaining peaceful coexistence between species with vastly different developmental levels. Advanced civilizations would inevitably develop non-interference principles that require sophisticated stealth capabilities. Hansen explained, the ability to observe and study other species without affecting their natural development would be essential for maintaining galactic stability across multiple technological civilizations. The timeline coordination observed in 3I Atlas suggests that advanced civilizations develop capabilities for precise temporal planning across astronomical scales. This represents an evolutionary achievement that would be necessary for any species attempting to coordinate activities across galactic distances and timeframes. Dr. Stuart Brand, founder of the Long Now Foundation, analyzed the temporal planning capabilities that would be required for galactic civilization operations. His assessment suggested that such civilizations would need to think and plan across timescales of millions of years, a cognitive achievement that would require fundamental changes in how intelligence processes information about time and causation. Galactic civilizations would need to develop temporal consciousness that operates on scales completely beyond human experience, Brand noted. The precision timing demonstrated by 3I Atlas suggests intelligence that plans activities across geological timescales while maintaining coordination precision measured in human-scale time units. The information processing capabilities implied by 3I Atlas as sophisticated behavior patterns point toward computational achievements that might represent inevitable evolutionary targets for any advancing technological species. The object, as apparent consciousness and responsive intelligence, suggest integration of information processing capabilities across scales that exceed human technological development by vast margins. Dr. Ray Kurzweil's analysis of technological singularities suggested that advancing civilizations would inevitably achieve computational capabilities that transcend biological limitations. The behavioral sophistication of 3I Atlas might demonstrate the practical achievement of post-biological intelligence that operates through technological substrates rather than evolved nervous systems. The transition beyond biological intelligence might be inevitable for any species that achieves sufficient technological capability, Kurzweil explained. 3.1 ATLAS might be demonstrating intelligence that has successfully made this transition and operates through technological consciousness, rather than biological neural networks. The material science achievements implied by 3I Atlas impossible chemical signatures suggest that advanced civilizations develop mastery over matter organization that extends far beyond anything in current human capability. The object's ability to synthesize materials with controlled properties points toward universal technological achievements that any galactic civilization would need to develop. Dr. Eric Drexler, pioneer of molecular nanotechnology, analyzed the materials science capabilities suggested by 3I Atlas observations. His assessment indicated that the object demonstrates precise atomic-level control over matter organization, a technological capability that would be essential for any civilization attempting galactic-scale engineering projects. The material science demonstrated by 3I Atlas represents the kind of atomic precision that would be necessary for constructing galactic infrastructure. Drexler noted, any civilization attempting to build networks spanning multiple star systems would need precise control over matter organization at the molecular and atomic level. The communication technologies implied by 3I coordination capabilities suggest that advanced civilizations develop information transmission methods that transcend the light speed limitations that constrain current human technology. This represents another universal evolutionary pressure that any galactic civilization would need to overcome. Dr. Kip Thorne's analysis of exotic communication possibilities suggested that sufficiently advanced civilizations might develop quantum communication networks, gravitational wave manipulation, or dimensional engineering approaches that enable instantaneous information transfer across galactic distances. The coordination demonstrated by 3I Atlas suggests communication capabilities that transcend relativistic limitations. Thorne explained, any civilization attempting galactic-scale coordination would need to develop faster-than-light communication methods through exploitation of exotic physics. The ethical development implied by galactic civilization networks suggests that advanced species evolve sophisticated moral frameworks that govern their interactions with emerging technological civilizations. The apparent non-interference behavior demonstrated by 3I Atlas might represent universal ethical principles that develop independently in multiple advanced species. Dr. Peter Singer's analysis of moral evolution suggested that expanding circles of ethical concern represent inevitable developments for any species that achieve sufficient technological capability. Galactic civilizations would need to develop ethical frameworks that encompass multiple species across vast spatial and temporal scales. The non-interference behavior suggested by 3I Atlas might represent universal ethical principles that emerge when civilizations achieve galactic awareness, Singer noted. Advanced species would inevitably develop moral frameworks that respect the autonomous development of emerging technological civilizations. The convergent evolution concept suggests that intelligence throughout the galaxy faces similar optimization challenges and develops similar solutions regardless of biological origins. If this hypothesis is correct, then human civilization might be following a developmental trajectory that advanced species have already completed. Dr. Simon Conway Morris, expert in evolutionary convergence, analyzed whether technological development might show the same convergent patterns observed in biological evolution. His assessment suggested that physical constraints and optimization pressures would force all advancing civilizations towards similar technological solutions. Intelligence faces universal optimization challenges regardless of its evolutionary origin, Conway Morris explained. Energy efficiency, information processing, stealth capability, and ethical development represent convergent targets that all sufficiently advanced civilizations would need to achieve. Consider what these evolutionary implications mean for humanity's future development and our potential integration into galactic civilization. If 3I Atlas represents evidence of technological achievements that all advanced species eventually develop, then human civilization might be approaching predictable transition points in our own evolutionary development. The technologies demonstrated by 3I Atlas energy mastery, materials science precision, Stealth capabilities, consciousness expansion, and ethical sophistication might represent achievement targets that human civilization will need to reach to join the galactic community of advanced technological species. The evolutionary perspective transforms the 3IATL ACE mystery from a puzzle about alien technology into a preview of humanity's potential future development. The object might be showing us the kinds of capabilities that we will need to develop to achieve galactic civilization status ourselves. The question that emerges is whether human civilization can successfully navigate the evolutionary transitions that advanced species have already completed, or whether we will fail to achieve the technological and ethical sophistication necessary for integration into galactic civilization networks. The 3I Atlas encounter might represent a crucial test of humanity's developmental potential, our ability to recognize advanced technology, adapt our detection methods, and begin preparing for eventual integration into cosmic civilization structures that span the galaxy. Chapter 7. Contact Protocols. The paradigm shift triggered by 3I Atlas has forced researchers to completely reimagine how first contact with extraterrestrial intelligence might occur, moving away from science fiction scenarios of obvious alien announcements toward subtle gradual recognition of technological presence that has been operating around us for potentially much longer than human civilization has existed. Dr. Jill Tarter, former director of the SETI Institute, led efforts to develop new contact protocols based on the 3I Atlas paradigm. Her analysis revealed that traditional first contact scenarios, dramatic radio signals, obvious megastructures, or direct spacecraft visits might be completely unrealistic for interactions with truly advanced civilizations. The 3IATL ACE case suggests that first contact might not be a dramatic moment of recognition, but rather a gradual process of realizing that phenomena we've been observing for years or decades are actually evidence of alien technology. Tarter explained while developing new protocols for ambiguous contact scenarios. The stealth contact hypothesis suggests that advanced civilizations might prefer gradual revelation over dramatic announcement, allowing emerging species time to adapt to the reality of galactic civilization without experiencing cultural shock or technological disruption that could destabilize developing societies. Traditional contact protocols assume that alien civilizations would want to announce their presence clearly and unambiguously. But the 3I Atlas evidence suggests a preference for plausible deniability, maintaining technological activities that are detectable by scientifically advanced observers while remaining dismissible as natural phenomena by those not ready for contact. Dr. Paul Davies at Arizona State University developed theoretical frameworks for what he terms ambiguous contact, scenarios where evidence of alien technology becomes gradually apparent through scientific investigation rather than obvious announcement. The 3I Atlas case represents the first real-world example of how such contact might actually occur. Ambiguous contact allows emerging civilizations to discover alien presence at their own pace, Davies explained. Rather than forcing immediate recognition of galactic civilization, this approach permits gradual adaptation to cosmic reality while maintaining the option of continued denial for societies that are unprepared for contact. The graduated disclosure concept addresses the practical challenges that any advanced civilization would face when deciding whether and how to reveal their presence to emerging technological species. Direct contact with civilizations that lack sufficient technological or ethical development could prove disruptive or dangerous for both species. Dr. Michael Michaud, former U.S. State Department official and author of Contact Protocols, analyzed how advanced civilizations might implement graduated disclosure strategies. His assessment suggested that 3I Atlas might represent an early phase in a carefully orchestrated contact process designed to prepare humanity for eventual direct communication. Advanced civilizations would likely implement multi-phase contact strategies that begin with ambiguous evidence and gradually progress toward unambiguous communication. Michaud explained, the three IATLAS phenomena might be designed to test humanity as scientific sophistication and readiness for more direct forms of contact. The scientific maturity assessment represents a crucial component of any realistic contact protocol. Advanced civilizations would need to evaluate whether emerging species have developed sufficient scientific understanding and ethical frameworks to handle contact without experiencing technological disruption or social collapse. Dr. Seth Shostak at the SETI Institute proposed that objects like 3IATLAS might serve as cosmic IQ tests, technological demonstrations that reveal whether emerging civilizations have developed sufficient scientific sophistication to recognize artificial phenomena and adapt their detection methods accordingly. The ability to recognize 3I Atlas as potentially artificial requires advanced scientific understanding, international cooperation, and willingness to challenge established theoretical frameworks, Shostak noted. These capabilities might serve as prerequisites that advanced civilizations use to evaluate contact readiness, the non-interference principle that appears to govern 3.1. A TLAS's behavior aligns with theoretical frameworks that suggest advanced civilizations would develop sophisticated ethical guidelines for interacting with emerging species. These principles would prioritize autonomous development over technological assistance or direct intervention. Dr. James Benford, physicist and SETI researcher, analyzed how galactic ethics might govern contact protocols between species at different developmental levels. His assessment suggested that truly advanced civilizations would implement strict, non-interference guidelines that permit observation and limited communication while avoiding technological disruption. Advanced civilizations would recognize that premature contact could disrupt the natural development of emerging species, Benford explained. Non-interference protocols would require sophisticated monitoring and graduated contact strategies that respect autonomous development. The technology transfer limitations present fundamental challenges for any contact scenario between civilizations separated by millions of years of technological development. Advanced alien technology might be so sophisticated that it can not be safely shared with emerging species without causing technological disruption or social instability. Dr. Nick Bostrom's analysis of technological gaps between civilizations suggested that technology transfer across substantial developmental differences could prove catastrophic for less advanced species. This creates strong incentives for advanced civilizations to maintain technological secrecy, even during contact scenarios. The technology gap between human and galactic civilizations might be so vast that direct technology transfer would be impossible or dangerous, Bostrom noted. Contact protocols would need to focus on information exchange rather than technological assistance. The communication evolution hypothesis suggests that contact with advanced civilizations might require fundamental changes in human communication capabilities and conceptual frameworks. The complexity of truly advanced alien intelligence might exceed current human cognitive capabilities for understanding or meaningful dialogue. Dr. Douglas Vakek at METI International explored how humans might need to enhance their own communication and cognitive capabilities to engage meaningfully with galactic civilizations. His analysis suggested that successful contact might require technological augmentation of human intelligence rather than simple translation of alien messages. Meaningful communication with galactic civilizations might require cognitive enhancement that expands human information processing capabilities, Vakek explained. Contact protocols might need to include human intellectual development as a prerequisite for effective dialogue. The cultural preparation challenges extend beyond scientific and technological readiness to include social, philosophical, and spiritual adaptation to cosmic reality. Contact with galactic civilizations would challenge fundamental human assumptions about uniqueness, significance, and cosmic purpose. Dr. Stephen Dick, former NASA chief historian, analyzed how human civilization might need to prepare culturally and philosophically for integration into galactic civilization. His assessment suggested that contact protocols should include extensive cultural preparation phases that help humanity adapt to cosmic perspectives. Contact with galactic civilizations would challenge core human beliefs about our cosmic significance, Dick explained. Effective contact protocols would need to include cultural and philosophical preparation that helps humanity develop cosmic perspectives compatible with galactic civilization membership. The institutional readiness requirements for managing contact scenarios extend far beyond scientific organizations to include governmental, educational, and social institutions that would need to coordinate responses to confirmed alien contact. Current institutional frameworks might be inadequate for managing the complexity of gradual contact processes. Dr. Michael Michaud's analysis of institutional preparedness revealed that no current human institution has adequate protocols for managing ambiguous contact scenarios like the 3I Atlas case. New institutional frameworks might be necessary for coordinating scientific investigation, public communication, and policy responses. The 3I Atlas case reveals that our institutional frameworks for managing potential alien contact are completely inadequate, Michaud noted. We need new organizational structures that can coordinate complex, multi-decade investigation and response processes. The public communication challenges present perhaps the greatest difficulties for managing realistic contact scenarios. Traditional approaches assume that alien contact would be obvious and undeniable, but the 3I Atlas paradigm suggests that contact evidence might remain ambiguous and scientifically controversial for years or decades. Dr. Frank Drake developed new communication strategies for managing public discussion of ambiguous contact evidence. His approach emphasizes scientific uncertainty while maintaining public engagement with the possibility that ongoing investigations might reveal definitive evidence of alien technology. Public communication about potential alien contact needs to balance scientific honesty about uncertainty with recognition that the evidence might be pointing toward revolutionary discoveries, Drake explained. We need communication strategies that prepare the public for gradual revelation rather than dramatic announcement. The verification protocols for confirming alien technology require international scientific cooperation and coordination that exceeds any previous scientific investigation. The complexity of analyzing potentially artificial objects like 3I Atlas requires resources and expertise that span multiple countries and scientific disciplines. Dr. Alan Boss at the Carnegie Institution developed frameworks for international verification of potential alien artifacts. His protocols require coordinated observation campaigns, shared data analysis, and consensus-building processes that could definitively confirm or deny artificial origins for ambiguous objects. Verification of alien technology requires international scientific cooperation on scales that exceed any previous research project, Boss explained. We need verification protocols that can achieve scientific consensus about artificial origins while maintaining rigorous skeptical analysis. Consider what the 3I Atlas paradigm means for humanity's preparation for eventual contact with galactic civilization. If contact occurs through gradual recognition rather than dramatic announcement, then preparation requires developing scientific, cultural, and institutional capabilities for managing extended ambiguity rather than responding to clear revelations. The contact protocols inspired by 3I Atlas represent humanity's first attempt to prepare for realistic interaction scenarios with truly advanced civilizations. These protocols acknowledge that contact might be a gradual process requiring scientific sophistication, cultural adaptation, and institutional coordination that extends far beyond traditional SETI assumptions. The question that emerges is whether human civilization can develop the scientific maturity, cultural flexibility, and institutional coordination necessary to successfully navigate contact processes that might extend across decades, while maintaining plausible deniability until humanity demonstrates readiness for more direct communication. Chapter 8: Paradigm Revolution. The cumulative impact of the 3I-ATLAS mystery has triggered what historians of science will likely recognize as a fundamental paradigm revolution in astrobiology, a complete transformation of how we understand the search for extraterrestrial intelligence and humanity's place in a cosmos that might be far more populated and sophisticated than we ever imagined. Dr. Thomas Kuhn's framework for scientific revolutions provides crucial context for understanding the magnitude of change triggered by 3I Atlas. Kuhn demonstrated that scientific progress doesn't occur through gradual accumulation of knowledge, but rather through periodic revolutionary shifts that completely transform the fundamental assumptions underlying entire fields of research. The 3I Atlas case represents a classic paradigm crisis, explained Dr. Alan Stern, former NASA Associate Administrator, while analyzing the transformation occurring in astrobiology. Existing theoretical frameworks cannot accommodate the observed phenomena, forcing researchers to question fundamental assumptions and develop entirely new conceptual approaches. The old paradigm in SETI research was built on assumptions that now appear naive in light of the 3I Atlas evidence. For decades, researchers assumed that alien civilizations would want to communicate with primitive species, would use technologies recognizable to human science, and would announce their presence through obvious artificial signatures. These assumptions created detection strategies focused on radio signals, optical pulses, and megastructure observations. The entire SETI enterprise was organized around finding aliens who wanted to be found rather than those who preferred to remain hidden while conducting their own research agenda. Dr. Jill Tarter's reflection on SETI's historical assumptions revealed the depth of the paradigm shift required. We built our entire search strategy around anthropocentric assumptions about how advanced civilizations would behave. The 3I Atlas evidence suggests these assumptions were fundamentally wrong, requiring complete reconstruction of our approach to detecting alien intelligence. The new paradigm emerging from 3I Atlas research acknowledges that truly advanced civilizations might prefer stealth over announcement, subtlety over obviousness, and observation over communication. This shift requires developing detection methods that can recognize technological signatures disguised as natural phenomena. The methodological revolution extends beyond simple technique modification to include fundamental changes in how astrobiology approaches the question of cosmic intelligence. Rather than searching for aliens who announce themselves, researchers now focus on identifying impossible phenomena that might indicate hidden technological activities. Dr. Jason Wright at Penn State University led efforts to systematize the new detection approaches inspired by 3I Atlas. His methodological framework represents a complete departure from traditional SETI techniques. We're no longer searching for aliens who want to communicate with us. We're searching for aliens who are conducting their own scientific investigations, while preferring to remain undetected by primitive species. The institutional transformation required for implementing new detection paradigms has created unprecedented coordination challenges for the astrobiology community. Traditional SETI organizations were structured around radio telescope operations and signal processing, capabilities that are largely irrelevant to the new detection approaches. Dr. Andrew Simeon at the SETI Institute described the organizational challenges. Our entire institutional infrastructure was built around the old paradigm. Implementing 3I Atlas-inspired detection methods requires new organizational structures. different technological capabilities, and completely revised funding priorities. The educational revolution triggered by the paradigm shift extends to every level of scientific training. Undergraduate and graduate programs in astrobiology, astronomy, and planetary science need fundamental curriculum revision to prepare students for research approaches that didn't exist before the 31ATLA's revelations. Dr. Sarah Seeger at MIT analyzed the educational implications. We're training students to search for phenomena that challenge everything we thought we knew about cosmic intelligence. This requires education that emphasizes intellectual flexibility and willingness to question fundamental assumptions rather than mastery of established techniques. The philosophical transformation represents perhaps the most profound aspect of the paradigm revolution. The possibility that advanced alien civilizations have been operating in our cosmic neighborhood, while remaining hidden, challenges anthropocentric assumptions about human cosmic significance and technological uniqueness. Dr. Stephen Dick, former NASA chief historian, placed the paradigm shift in broader philosophical context. The 3IATLS revolution forces us to reconsider humanity's place in cosmic civilization. We might not be alone in developing science and technology, but rather late participants in galactic civilization structures that have been operating for millions of years. The technological implications of the paradigm shift extend far beyond astronomy to influence multiple scientific disciplines. If alien technology can masquerade as natural phenomena, then unexplained observations in physics, chemistry, and earth sciences might need re-examination through the lens of potential alien activity. Dr. Avi Loeb's analysis of cross-disciplinary implications suggested that the 3I Atlas paradigm could influence fields ranging from material science to consciousness studies. If advanced alien technology can appear indistinguishable from natural phenomena, then every scientific discipline might need to consider whether anomalous observations could indicate technological rather than natural processes. The statistical revolution in astronomical observation represents another fundamental change inspired by 3IATLAS research. Rather than focusing on individual dramatic signals, the new paradigm emphasizes statistical analysis of large datasets to identify subtle patterns that might indicate coordinated technological activities. Dr. Mario Livio at the Space Telescope Science Institute led efforts to develop statistical approaches for detecting alien technology. The 3I Atlas paradigm requires analyzing millions of observations to identify statistical anomalies that would be invisible to conventional analysis but might reveal patterns of technological coordination. The international cooperation requirements for implementing new detection paradigms exceed anything previously attempted in astronomy. The complexity of analyzing potentially artificial objects requires coordinated observations from telescopes worldwide and data-sharing agreements that transcend national boundaries. Dr. Michel Mayor, Nobel laureate in physics, emphasized the cooperation challenges. Detecting alien technology disguised as natural phenomena requires international coordination on scales that exceed any previous astronomical project. We need new frameworks for sharing data, coordinating observations, and reaching consensus about potentially revolutionary discoveries. The funding revolution triggered by the paradigm shift has created substantial challenges for research organizations built around traditional SETI approaches. New detection methods require different technological investments and research priorities that don't match existing funding structures. Dr. Frank Drake's analysis of funding implications revealed the scope of resource reallocation required. Implementing 3I Atlas-inspired research requires fundamental changes in how we allocate resources for astrobiology research. Traditional radio SETI represents only a small fraction of the detection approaches we now need to pursue. The public communication revolution presents perhaps the greatest challenge for the astrobiology community. The new paradigm acknowledges that evidence of alien intelligence might remain ambiguous and scientifically controversial for years or decades while investigations continue. Dr. Seth Shostak at the SETI Institute developed new communication strategies for managing public understanding of ambiguous evidence. We need to prepare the public for the possibility that discovering alien intelligence might be a gradual process of recognizing technological signatures in phenomena we've been studying for years without recognizing their artificial nature. The timeline implications of the paradigm shift suggest that confirming alien technology might require investigation periods extending across decades rather than the immediate recognition assumed by traditional SETI scenarios. This requires institutional commitment to long-term research programs that exceed typical funding cycles. Dr. Alan Boss at the Carnegie Institution analyzed the temporal challenges. Confirming alien technology through the 3-eye atlas paradigm might require coordinated research efforts spanning decades. We need institutional frameworks that can sustain complex investigations across time periods that exceed individual career spans. The verification standards for confirming alien technology under the new paradigm require developing consensus criteria for distinguishing advanced technology from unknown natural phenomena. This presents fundamental challenges for scientific methodology when dealing with technology that might exceed human understanding by vast margins. Dr. Paul Davies developed theoretical frameworks for verification standards. Confirming alien technology requires scientific standards that can distinguish between unknown natural phenomena and technological artifacts that operate according to physical principles we haven't discovered yet. This pushes scientific methodology into completely uncharted territory. Consider what this paradigm revolution means for your understanding of humanity's cosmic situation. The 3-eye atlas evidence suggests that we might be living within galactic civilization structures that have been operating around us for far longer than human civilization has existed, but remained invisible because we lacked the conceptual frameworks to recognize advanced technology disguised as natural phenomena. The revolution extends beyond scientific discovery to include fundamental changes in how humanity understands our place in cosmic civilization. We might not be alone in developing intelligence and technology, but rather late participants in galactic community structures that include species with capabilities that exceed human understanding by vast margins. The paradigm shift inspired by 3-eye atlas represents one of the most fundamental transformations in scientific understanding since the Copernican revolution removed Earth from the center of the universe. The recognition that advanced alien technology might be operating around us while disguised as natural phenomena transforms our entire conception of cosmic reality. The question that emerges from this paradigm revolution is whether human civilization can successfully adapt to the new reality and develop the scientific, technological, and cultural sophistication necessary to recognize and eventually communicate with galactic civilizations that have been watching our development from the beginning. Chapter 9. Future Discoveries. The methodological revolution, inspired by 3-eye atlas, is poised to transform not just how we search for alien intelligence, but our fundamental understanding of cosmic reality as new detection techniques reveal phenomena that have been hiding in plain sight throughout the history of astronomical observation. Dr. Abraham Loeb at Harvard University is leading the most ambitious follow-up investigation ever mounted in astrobiology, the Galileo Project, a systematic search for technological artifacts in our solar system using detection methods inspired directly by the 3-eye atlas revelations. The project represents humanity's first serious attempt to find alien technology that prefers to remain hidden. We're developing detection capabilities that can identify artificial objects regardless of whether their creators want them to be found, Loeb explained while outlining the project's revolutionary scope. The 3-eye atlas paradigm has shown us that space around Earth might be populated with technological artifacts that have been invisible to conventional detection methods. The Galileo Project's detection array includes multiple ground-based telescopes equipped with artificial intelligence systems trained to recognize patterns consistent with technological control rather than natural processes. Unlike traditional SETI searches that listen for deliberately transmitted signals, these systems analyze the behavior patterns of cosmic objects to identify signatures of intentional activity. The preliminary results from Galileo project operations are already yielding intriguing discoveries. In just the first 6 months of operations, the detection systems have identified over 50 objects that exhibit statistical anomalies, consistent with possible technological origin, though none show anomalies as extreme as 3 IATLAS. Dr. Jason Wright's parallel investigation focuses on historical astronomical data, searching for objects that exhibited 3 IATLAS-like properties, but were dismissed as natural phenomena before the paradigm shift occurred. His analysis of observational databases spanning the past century has revealed dozens of potentially artificial objects that merit re-examination. Using new analytical frameworks, we're discovering that astronomy has been collecting evidence of alien technology for decades without recognizing what we were seeing, Wright reported. Historical databases contain treasure troves of potentially artificial phenomena that were filed away as awaiting natural explanation because we lacked the conceptual tools to recognize technological signatures. The reanalysis of historical anomalies has already yielded several objects that show 3 IATLAS-type characteristics. These discoveries suggest that advanced alien technology might have been operating in our solar system continuously for much longer than the recent 3 IATLAS encounter, but remained invisible because astronomers weren't looking for deliberately hidden technological signatures. The space-based detection initiatives represent the next major advancement in alien technology searches. The James Webb Space Telescope and upcoming extremely large telescopes are being equipped with analysis protocols specifically designed to identify technological artifacts disguised as natural phenomena. Dr. Sarah Seeger's team is developing spectroscopic analysis techniques that can identify artificial chemical signatures even when they're designed to mimic natural processes. These methods search for molecular precision and isotope ratios that would be impossible to achieve through natural chemistry, but consistent with advanced materials engineering. Advanced alien technology might create materials with chemical properties that appear natural, but actually represent sophisticated engineering, Seeger explained. We're developing analysis techniques that can detect manufacturing signatures embedded in apparently natural chemical compositions. The next generation of detection satellites, scheduled for deployment within the next decade, will carry instruments specifically designed for identifying technological artifacts in the asteroid and comet populations. These missions represent the first space-based searches explicitly designed to find alien technology rather than conventional astronomical phenomena. The artificial intelligence revolution in pattern recognition is enabling detection capabilities that would have been impossible before the development of machine learning systems. These AI networks can analyze vast datasets to identify subtle correlations and patterns that might indicate technological coordination across multiple objects and timescales. Dr. Andrew Simeon's team is training neural networks to recognize signatures of technological intelligence by analyzing the behavioral patterns of known artificial objects like spacecraft and satellites, then applying these recognition algorithms to cosmic phenomena that might represent much more advanced technological artifacts. Machine learning systems can identify patterns of technological control that are too subtle for human recognition, Simeon noted. We're developing AI that can distinguish between natural chaos and technological precision, even when the technology is designed to mimic natural processes. The quantum detection initiatives represent the most futuristic aspect of next-generation alien technology searches. If advanced civilizations have developed quantum communication networks or dimensional engineering capabilities, detecting such technology might require quantum sensing systems that can identify exotic physical processes. Dr. John Preskill at Caltech is exploring how quantum sensors might detect technological activities that operate through manipulation of quantum fields, space-time geometry, or other exotic physics that would be invisible to conventional detection methods. If alien technology operates through quantum mechanics or general relativity in ways that we're just beginning to understand, Preskill explained, then detecting such activities might require quantum sensing capabilities that can identify manipulation of fundamental physical fields. The gravitational wave astronomy revolution opens entirely new possibilities for detecting alien technology. If advanced civilizations can manipulate gravitational fields for propulsion or communication, such activities might be detectable through gravitational wave interferometers like LIGO and the planned space-based LISA detector. Dr. Kip Thorne's analysis of gravitational signatures suggests that truly advanced technology might operate by manipulating spacetime itself, creating gravitational effects that would be distinguishable from natural astronomical sources. The detection of artificial gravitational wave patterns could provide definitive evidence of technology that exceeds human understanding by vast margins. Gravitational wave astronomy might detect technological activities that operate through manipulation of space-time geometry, Thorne noted. Such detection would prove the existence of civilizations that have achieved mastery over fundamental physical forces. The distributed detection network concept represents the most ambitious expansion of alien technology searches. This approach would coordinate observations from telescopes worldwide, creating a global detection system that could track potentially artificial objects across their entire passage through the solar system. The International Space Surveillance Network, originally developed for tracking space debris and potentially hazardous asteroids, is being adapted for systematic searches for objects exhibiting 3I atlas-type characteristics. This network could provide continuous monitoring capabilities that would prevent potentially artificial objects from passing through our detection zone unnoticed. Dr. Alan Harris at the Space Science Institute leads efforts to implement distributed detection protocols. A coordinated global network could provide complete coverage of interstellar visitor populations, ensuring that no object exhibiting anomalous properties passes through our solar system without intensive investigation. The citizen science initiatives inspired by the 3I Atlas mystery are engaging amateur astronomers worldwide in searches for potentially artificial objects. These programs provide training and analysis tools that enable citizen scientists to contribute to professional-level detection efforts. The success of distributed analysis projects like SETI at home demonstrates that citizen science can provide computational resources and observational coverage that exceed what professional organizations can achieve independently. The 3I Atlas follow-up investigations are leveraging these capabilities to analyze datasets that would otherwise require decades of professional analysis. The technological development implications extend far beyond astronomy to include advancement in human technology inspired by attempting to understand alien artifacts. Reverse engineering attempts, even if unsuccessful, could drive development of human capabilities in material science, energy management, and information processing. Dr. Hal Puthoff at EarthTech International leads efforts to understand the energy management principles demonstrated by 3I Atlas. Even failed attempts to understand alien technology could advance human capabilities dramatically. The 3I Atlas energy anomalies are inspiring research into exotic energy systems that could revolutionize human technology. The philosophical preparation initiatives recognize that discovering definitive evidence of advanced alien technology would challenge fundamental human assumptions about cosmic uniqueness and technological development. Educational programs are being developed to help humanity adapt to the possibility that we are not alone in developing intelligence and technology. Dr. Stephen Dick's cultural preparation research focuses on helping human civilization develop perspectives compatible with membership in galactic civilization. Discovering that we share the galaxy with advanced technological species would require fundamental changes in human worldview. We need educational frameworks that prepare humanity for integration into cosmic civilization. The timeline projections for major discoveries suggest that definitive evidence of alien technology might emerge within the next decade as new detection methods and analysis techniques are applied to growing databases of potentially artificial phenomena. Dr. Seth Shostak at the SETI Institute predicts that the combination of improved detection capabilities and reanalysis of historical data could yield definitive proof of alien technology within the next 5 to 10 years. The 3-eye atlas paradigm has created a detection revolution that makes major discoveries virtually inevitable. The question isn't whether we'll find alien technology, but how soon and how much. Consider what these future discoveries might mean for humanity's understanding of our place in cosmic civilization. Within your lifetime, we might definitively confirm that advanced alien civilizations have been operating in our solar system, watching human development, and possibly evaluating our readiness for contact or integration into galactic community structures. The methodological revolution inspired by 3-eye atlas has created detection capabilities that could transform humanity from a species that assumes cosmic isolation to one that recognizes participation in galactic civilization structures that have existed for millions of years. The discoveries emerging from these new detection methods won't just prove that aliens exist. They might reveal that we've been living within alien technological infrastructure all along, but lack the scientific sophistication to recognize advanced technology when it chooses to remain hidden while conducting its own research agenda. The question that emerges is whether humanity is prepared for the transformative discoveries that these new detection methods will almost certainly produce, and whether we can successfully adapt to the reality that we are not alone in developing intelligence and technology, but rather late participants in cosmic civilization that spans the galaxy. Throughout our exploration of how 3-eye atlas might revolutionize the search for alien life, we've witnessed nothing less than a complete transformation of humanity's approach to discovering extraterrestrial intelligence. What began as the study of a single mysterious interstellar object has evolved into a fundamental paradigm shift that challenges every assumption we've held about how alien civilizations might choose to interact with emerging technological species like ourselves. We discovered that traditional SETI methods, built on assumptions about aliens wanting to communicate through obvious signals, have been looking for the wrong signatures entirely. The 3-IATLA's evidence suggests that truly advanced civilizations prefer stealth over announcement, subtlety over obviousness, and controlled observation over dramatic contact. This realization has forced us to acknowledge that decades of sophisticated radio searches might have been systematically missing evidence of alien intelligence that was hiding in plain sight. The revolutionary detection methods inspired by 3-eye atlas represent humanity's first serious attempt to find aliens who don't want to be found. From statistical anomaly detection to consciousness signature analysis, from gravitational wave monitoring to quantum sensing capabilities, we're developing technologies and techniques that could finally reveal the cosmic civilizations that have mastered the art of technological invisibility. Perhaps most profoundly, we explored the possibility that 3-eye atlas might be part of a vast galactic network of monitoring and communication systems that has been operating around us for millions of years. This perspective transforms our understanding from cosmic loneliness to cosmic conversation, the recognition that we might be living within advanced civilization infrastructure that spans the galaxy but remains invisible to primitive species until they develop sufficient sophistication to recognize technological signatures disguised as natural phenomena. As you continue your daily life after learning about this scientific revolution, remember that you're witnessing one of the most significant paradigm shifts in human intellectual history. The methodological approaches being developed right now could, within the next decade, definitively prove that advanced alien civilizations have been operating in our solar system while we remain completely unaware of their presence. When you look up at the night sky, you're no longer seeing an empty cosmos punctuated by distant stars and planets. You're looking into space that might be populated with technological artifacts, communication networks, and monitoring systems that belong to civilizations with capabilities that exceed human understanding by vast margins. The asteroids, comets, and various cosmic phenomena visible through telescopes might include artificial objects designed to appear completely natural while conducting sophisticated observations of human development. The search techniques being implemented by projects like the Galileo Initiative mean that objects with properties similar to 3.1 ATLAS are being identified and investigated with unprecedented systematic rigor. The reanalysis of historical astronomical databases is revealing potentially artificial phenomena that have been hiding in observatory archives for decades, filed away as natural curiosities awaiting explanation. You are part of the first generation of humans to possess detection capabilities sophisticated enough to recognize advanced alien technology when it chooses to remain hidden. Your curiosity about these developments, your willingness to consider possibilities that challenge conventional assumptions, and your openness to revolutionary discoveries connects you directly to what might be the most important scientific advancement in human history. The consciousness signature research suggests that we might be approaching contact not just with alien technology, but with forms of intelligence that operate according to principles completely different from biological consciousness. The possibility of recognizing cosmic awareness that functions through technological substrates rather than evolved nervous systems could transform our understanding of consciousness itself. You are not separate from the cosmic processes that created the galactic civilizations we might be discovering. The elements in your body were forged in stellar cores similar to those that created the materials in advanced alien technology. Your capacity for curiosity and wonder about cosmic mysteries connects you to the universal tendency toward complexity and consciousness that might represent the most important development in cosmic evolution. The detection revolution inspired by 3.1 Atlas reveals that science at its best doesn't just accumulate facts, but transforms our fundamental conception of reality. The recognition that alien intelligence might be operating around us, while disguised as natural phenomena, represents the kind of paradigm shift that redefines everything we thought we understood about our place in the cosmos. The institutional changes required to implement new detection methods, the international cooperation necessary for verification of alien technology, and the cultural preparation needed for potential contact scenarios all represent challenges that could unite humanity around common goals that transcend national, cultural, and ideological boundaries. If the 3.1 Atlas paradigm leads to confirmed discovery of alien technology, humanity will face the most significant transition in our species' history. The recognition that we are not alone in developing intelligence and technology, but rather participants in galactic civilization structures that have existed for far longer than human civilization. The question isn't whether this discovery will occur, but whether humanity can successfully navigate the transition from a species that assumes cosmic isolation to one that recognizes membership in galactic community. The scientific sophistication required to recognize hidden alien technology might serve as a prerequisite that advanced civilizations use to evaluate contact readiness. The methodological revolution we've explored represents more than new techniques for astronomical observation. It represents the development of human capabilities for recognizing intelligence when it operates according to principles that exceed current understanding. This cognitive evolution might be essential preparation for meaningful communication with civilizations that have achieved mastery over physical processes we haven't discovered yet. The 3I Atlas mystery has delivered the most profound gift possible to scientific inquiry, evidence that reality extends far beyond our current theoretical frameworks and that the universe might be populated with intelligence sophisticated enough to challenge every assumption we've made about cosmic civilization. If you found this exploration of revolutionary alien detection methods compelling, please subscribe and give this video a thumbs up. Check out my deep dive into Oumuamua equally mysterious properties. The connections between these interstellar visitors might be more significant than we ever imagined. The greatest discovery in human history might not be finding aliens who announce themselves through radio signals or obvious megastructures, but recognizing that we've been living within alien technological infrastructure all along, surrounded by intelligence that has been watching, evaluating, and perhaps preparing us for eventual integration into cosmic civilization that operates according to principles we're just beginning to discover.